My name is Patrice Godefroid. I'm a researcher at Microsoft Research. My area of research is software analysis, testing, and verification. Today I want to tell you about some recent work we've been doing on REST API fuzzing. So what is REST API fuzzing? Well, as you know, cloud computing is currently exploding. There are more and more cloud services available every day. Most cloud services access programmatically through REST APIs, both by other services and by third-party applications. REST APIs are implemented on top of the HTTPS protocol stack and offer a uniform way to manage cloud services. Cloud service developers can document their REST APIs using interface description languages like OpenAPI, also known as Swagger. An OpenAPI specification describes how to access a cloud service through its REST API, including what requests the service can handle, what responses may be received, and the exact formats for requests and responses. REST APIs can be very complex. For instance, REST APIs of Azure services are described in millions of lines of OpenAPI code publicly available on GitHub. To master this complexity, we need new tools to prevent expensive bugs in cloud services. At Microsoft Research, we have recently developed RESTler, the first stateful REST API fuzzer. RESTler is a tool that takes as input an OpenAPI specification and then automatically generate and execute tests from that specification. So with RESTler, you do not need a test suite or pre-recorded API traffic to start. RESTler automatically generates API traffic from scratch, directly from an OpenAPI specification. It will generate lots of requests, some well-formed requests and some badly formed requests to try to trigger bugs in the cloud services being tested. That's what fuzzing means. During its testing, RESTler can find all kinds of bugs in cloud services, such as HTTP 500 internal server errors, which are unhandled exceptions. That is, these are crashes in the cloud services being tested. RESTler also checks for specific API properties, such as a use after free should never happen. If RESTler creates a new resource and then deletes it, RESTler should not be able to reaccess this specific resource later on, after it's been deleted. If this ever happens, RESTler reports an error. RESTler also includes checkers for several other properties that should hold for every API. So how does RESTler work? Well, my colleague Marina will tell you more about this.
Thank you, Patrice. Hello, everyone. My name is Marina Polishchuk. I'm a software engineer at Microsoft Research. RESTler has two main components, a compiler and an engine. So the compiler analyzes a Swagger specification and generates a fuzzing grammar, which contains information about all of the schemas of the requests and their responses, as well as producer-consumer dependencies. Producer-consumer dependencies are a unique feature of RESTler that allow it to more deeply cover services out of the box automatically. What are producer-consumer dependencies? Well, if say one request produces or creates, for example, a resource that is then consumed or taken as parameters by subsequent requests, RESTler will be able to infer that ordering constraint and will be able to extract those IDs, names, or some other property out of the responses of the first request and specify in the specification that the second request should take those as a parameter. The RESTler engine will take the fuzzing grammar and execute tests and actually report bugs that are found in the course of test execution. Tests here are going to be sequences of requests, and the engine uses a systematic state space search to cover those sequences, and it also has some algorithms to eliminate redundant requests to avoid fuzzing the same things over and over. So those of you who have done some fuzzing, you may know that there's a lot of repetitive kind of coverage that gets generated during fuzzing. And RESTler, for example, will detect that if, say, requests ABC were executed in a sequence BAC and C returned a 400 or bad request, RESTler will say, oh, this means that the service, when passed an invalid input after that sequence, handles it gracefully and it doesn't have any bug to report, so it'll avoid trying that sequence in the future. There are four main modes in which RESTler works. The first mode, compile, takes your API specification and produces the fuzzing grammar, as well as some default configuration files that you can then customize, such as a fuzzing dictionary and the engine settings. The next phase is a test phase. The test phase tries to execute each request in the specification and in as minimum number of steps as possible. So it'll only execute the dependent requests as well as the request itself, and it'll try as many parameters as needed to try to get a successful request to execute. And then what it outputs is a coverage file, and this file will tell you how many requests were executed and how many of them were successful, and in detail all of the other return codes and responses for all the failing requests. So for example, if your service has 110 requests and RESTler, say, successfully executed 50 of them, well, that might seem like low coverage, but you may still get a lot of value out of fuzzing those 50 requests. And so you may say you're not going to customize anything else, you just go on and do fuzzing in the next phase. Or, in some cases, 0 requests may be covered. The most common of those cases is if there is some, say, path parameter that's really a magic value, it's not produced by anything in this particular API. For example, a tenant ID that always has to be specified to this API, then you can put that in the dictionary file and try the test phase again until you do get some positive coverage. The next phase of RESTler is a fuzzing mode, and we have several. We have a full fuzzing mode as well as kind of a lean fuzzing mode that allows you to, say, quickly find some bugs by executing the RESTler checkers, which check security properties, together with more efficient fuzzing algorithm. And the replay mode is the last mode of RESTler, and this allows you to quickly reproduce all of the bugs that were reported during fuzzing using RESTler itself and the files that it produces. I should mention that RESTler has been used at Microsoft to find bugs in many services across Office 365, Bing, and Azure. And all of these bugs have been fixed. You can find some specific data if you're interested in case studies in some of our recent papers, such as the ICST 2020 and FSC 2020 conference papers. Now, after you've tried RESTler and found a few bugs, you may ask, well, how do I run RESTler regularly? What do I need to do to integrate RESTler in my CI/CD pipeline? Microsoft Research has also released a REST API fuzz testing toolkit, which is a self-hosted Azure service that you can deploy, and it has several tools configured out of the box, such as RESTler and OWASP Zap and a few more. And you can very easily add other API testing, API fuzzing tools that you would like into this framework. It'll also allow you to deploy your service under test if it runs in a Docker container. Now, you can use this, for example, to run several tools in parallel if you want to scale your testing to many check-ins across many tools. Or you can also perform differential regression testing across, say, different API versions or across time for your services as they're being deployed.
Thank you, Marina. For more information, please visit these links. RESTler is available on GitHub, where you can find in our repo documentations and examples and the code and the research papers that we have published about it. And Raft is also available in its own GitHub repo. Please give these a try. Thank you very much for your attention.